Section 110.26 does indeed cover the installation of a 40 amp disconnect for an air conditioner. The essence of 110.26 is to ensure that every service, feeder, and branch circuit is equipped with a readily accessible means of disconnect at its origin. Let's break down what this entails. A disconnect, in electrical terms, is a device or a collection of devices designed to open all ungrounded conductors of a circuit through a single action. This is crucial for safety and maintenance. In the context of an air conditioner, the 40 amp disconnect serves precisely this purpose. It's installed at the origin of the circuit that powers the air conditioning unit, allowing for a safe and complete isolation of the appliance from the electrical system. This isolation is essential for conducting maintenance, performing repairs, or addressing any potential issues without the risk of electrical shock or further damage. The key point to remember is that the stipulations outlined in 110.26 are universally applicable. They don't discriminate based on the source of the circuit. Whether the circuit originates from a panel board or any other type of distribution point, the requirements remain the same. Therefore, the assertion that this code section applies exclusively to panel boards is inaccurate. The code's intent is to ensure safety across the board, regardless of the specific configuration of the electrical system. To elaborate further, it's important to understand the different types of circuits mentioned in 110.26, namely service, feeder, and branch circuits. Firstly, a service is the electrical supply from the utility company to the building. It's the primary source of power. Secondly, a feeder is a circuit that originates from the service equipment, such as a main panel board, and supplies power to one or more branch circuit overcurrent devices. Think of it as an intermediate distribution pathway. Thirdly, a branch circuit is the circuit that extends from the final overcurrent device protecting the circuit to the outlets, lights, and appliances that it supplies. In the case of the air conditioner, the circuit feeding it would typically be considered a branch circuit. The 40 amp disconnect would be placed at the beginning of that branch circuit, providing a means to shut off power specifically to the air conditioner. Now let's delve into the term readily accessible as it appears in the code. Readily accessible means capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. This is critical because, in an emergency or during maintenance, it must be possible to quickly and easily disconnect the power supply. If the disconnect is hidden behind equipment, locked away, or otherwise difficult to reach, it does not meet the requirements of the code. It is important to note that overcurrent protection plays a vital role in the safety of electrical circuits. Overcurrent protection devices such as circuit breakers and fuses are designed to interrupt the flow of electricity when the current exceeds the safe ampacity of the conductors. This prevents overheating, insulation damage, and potential fires. The 40 amp disconnect for the air conditioner would typically be installed in conjunction with a 40 amp overcurrent device. This ensures that the circuit is protected from overloads and short circuits. When selecting a disconnect switch for an air conditioner, several factors must be considered. Firstly, the voltage and amperage rating of the switch must be suitable for the circuit. In this case, a 40 amp switch would be appropriate for a 40 amp circuit. Secondly, the switch must be rated for the type of equipment being disconnected. Air conditioners typically have motors, and motor loads can have high inrush currents when they start. Therefore, the switch must be rated for motor applications. Thirdly, the switch must be suitable for the environment in which it will be installed. If the switch is located outdoors, it must be rated for outdoor use and protected from the elements. Proper grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source. This helps to trip over current devices quickly, minimizing the risk of electrical shock. The disconnect switch for the air conditioner must be properly grounded in accordance with the NEC. Grounding is typically achieved by connecting a grounding conductor from the disconnect switch to the grounding electrode system of the building. The NEC provides detailed requirements for grounding in Article 250. These requirements must be followed carefully to ensure a safe and effective grounding system. In addition to the general requirements of 110.26 TOR, there may be other applicable codes and standards that must be considered when installing a disconnect for an air conditioner. Firstly, local building codes may have additional requirements for electrical installations. It is important to check with the local building department to ensure compliance with all applicable codes. Secondly, the manufacturer's instructions for the air conditioner and the disconnect switch must be followed carefully. These instructions provide specific guidance on how to install and operate the equipment safely. Thirdly, industry standards such as those published by the National Electrical Manufacturers Association, or NEMA, may provide additional recommendations for electrical installations. These standards represent best practices and can help to ensure a safe and reliable installation. Regular inspection and maintenance are essential for the continued safety and reliability of electrical systems. Disconnect switches should be inspected periodically to ensure that they are in good working condition. Any damaged or worn component should be replaced promptly. Air conditioners should also be inspected and maintained regularly to ensure that they are operating safely and efficiently. Proper maintenance can help to prevent electrical problems and extend the life of the equipment. In summary, Section 110.26 of the NEC does apply to the installation of a 40-amp disconnect for an air conditioner. The code requires that all services, feeders, and branch circuits be provided with a readily accessible means of disconnect at the origin. This requirement is intended to ensure safety and facilitate maintenance. The disconnect switch must be properly sized, rated, and grounded, and all applicable codes and standards must be followed. Regular inspection and maintenance are essential for the continued safety and reliability of the electrical system. Now let's talk about some common mistakes that people make when installing disconnects. Firstly, failing to properly size the disconnect switch for the load. The disconnect switch must be rated for the voltage and amperage of the circuit it is disconnecting. If the switch is too small, it may overheat and fail. Secondly, neglecting to properly ground the disconnect switch. Grounding is essential for safety. The disconnect switch must be grounded in accordance with the NEC. Thirdly, installing the disconnect switch in an inaccessible location. The disconnect switch must be readily accessible for operation, renewal, or inspection. It should not be hidden behind equipment or locked away. Fourthly, failing to follow the manufacturer's instructions. The manufacturer's instructions provide specific guidance on how to install and operate the equipment safely. Fifthly, not performing regular inspections and maintenance. Regular inspection and maintenance are essential for the continued safety and reliability of electrical systems. Disconnect switches should be inspected periodically to ensure that they are in good working condition. Now let's discuss some advanced topics related to disconnects. Firstly, the use of fuse disconnects. A fuse disconnect is a disconnect switch that incorporates fuses. Fuse disconnects provide both a means of disconnecting the circuit and overcurrent protection. They are commonly used in applications where both functions are required. Secondly, the use of non-fuse disconnects. A non-fuse disconnect is a disconnect switch that does not incorporate fuses. Non-fuse disconnects are typically used in applications where overcurrent protection is provided by a separate device, such as a circuit breaker. Thirdly, the use of horsepower-rated disconnects. Horsepower-rated disconnects are specifically designed for disconnecting motor loads. They are rated to handle the high inrush currents that occur when motors start. Fourthly, the use of enclosed disconnects. Enclosed disconnects are disconnect switches that are mounted in an enclosure. Enclosures provide protection from the environment and prevent accidental contact with live parts. Fifthly, the use of safety switches. Safety switches are a type of enclosed disconnect that is designed to be operated with a padlock. This allows the switch to be locked in the open position, preventing accidental energization of the circuit. Now, let's consider a few practical scenarios involving disconnects. Firstly, imagine you are working on an air conditioner and need to disconnect the power. You would locate the disconnect switch for the air conditioner and turn it to the off position. This would isolate the air conditioner from the electrical system, allowing you to work on it safely. Secondly, suppose you are installing a new air conditioner. You would install a disconnect switch at the origin of the circuit that will supply power to the air conditioner. This would provide a means of disconnecting the air conditioner for maintenance or repairs. Thirdly, imagine you are troubleshooting an electrical problem in an air conditioner. You would use a disconnect switch to isolate the air conditioner from the electrical system. This would allow you to safely test the components of the air conditioner without the risk of electrical shock. Fourthly, suppose you are replacing a damaged disconnect switch. You would turn off the power to the circuit at the main panel board. Then, you would disconnect the wires from the old disconnect switch and connect them to the new disconnect switch. Finally, you would turn the power back on at the main panel board. Remember, safety is paramount when working with electricity. Always follow proper safety procedures and consult with a qualified electrician if you are unsure about anything. When referring to the National Electrical Code, it's important to use the correct terminology and understand the structure of the codebook. The NEC is organized into chapters, articles, and sections. Chapters are broad divisions of the code, such as Chapter 1, which covers general requirements. Articles are subdivisions of chapters and address specific topics, such as Article 250, which covers grounding and bonding. Sections are subdivisions of articles and provide detailed requirements for specific situations, such as Section 110.26, which covers working space about electrical equipment. When referencing a specific requirement in the NEC, it's important to include the chapter, article, and section number. For example, the requirement for working space about electrical equipment is found in Section 110.26. The NEC is updated every 3 years, so it's important to use the most current edition of the code. The current edition of the NEC is the 2023 edition. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA, or from many online retailers. It is essential to stay informed about changes to the NEC to ensure that your electrical installations comply with the latest requirements. Many resources are available to help you stay up to date on the NEC, including training courses, seminars, and online forums. In addition to the NEC, there may be other applicable codes and standards that you need to consider when installing electrical equipment. These codes and standards may include local building codes, state electrical codes, and industry standards. It is important to check with your local authorities to determine which codes and standards apply to your specific situation. Complying with all applicable codes and standards is essential for ensuring the safety and reliability of your electrical installations. When selecting electrical equipment, it is important to choose equipment that is listed and labeled by a recognized testing laboratory. Listing and labeling indicate that the equipment has been tested and found to comply with applicable safety standards. Recognized testing laboratories include Underwriters Laboratories, or UL, and Intertek, or ETL. Look for the UL or ETL mark on the equipment to ensure that it has been properly tested. Using listed and labeled equipment is an important step in ensuring the safety of your electrical installations. In conclusion, understanding and applying the requirements of the NEC is essential for ensuring the safety and reliability of electrical installations. Section 110.26 specifically addresses the need for a readily accessible disconnect for services, feeders, and branch circuits, including those serving air conditioners. By following the code and using proper installation techniques, you can help to prevent electrical hazards and protect people and property from harm. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. It is always beneficial to consult with a qualified electrician or electrical inspector for specific guidance and to ensure compliance with all applicable codes and regulations. Remember that this information is for educational purposes only and should not be considered a substitute for professional advice.